This is Mrs. Wainwright's Math Class, Chapter 2, Lesson 7, Interpreting Remainders. Our learning target, by the end of today's lesson, you should confidently be able to say, I can properly interpret the remainder in a word problem. We know that when we solve a division problem, sometimes we wind up with a remainder in our answer. But when there's a remainder in a division word problem, we always need to stop and think it out. We must interpret the given situation in that particular word problem to figure out what we need to do with the remainder and how it will affect the final answer. When you have a remainder in a division word problem, you have 4 choices, and you'll always need to do one of the following. Choice 1, you may need to ignore the remainder and just go with the whole number answer. Choice 2, you may need to include what the remainder is, so you would need to add 1 to the whole number quotient or answer. Choice 3, sometimes the remainder is the answer. If they only want to know what's left over, that's the remainder, so that would be the only answer. And choice 4, sometimes you can actually share the remainder. You can take what's left over and break it up. And you could break it up and show it by writing the remainder as either a fraction or a decimal. Until we get back to the chapter on decimals, we will be writing our remainders as fractions if we need to share the remainder and break it up. So let's take a look at some examples and see how this works. Question number 1 says Mrs. Wainwright has 17 Hershey Kisses. Surprise, surprise. She'll make Halloween bags with 3 kisses in each bag. How many Halloween bags can Mrs. W make? Okay, let's go back to our question. What exactly is this asking us? It's asking how many Halloween bags Mrs. Wainwright can make. Let's see what we know. We know that Mrs. Wainwright has 17 Hershey Kisses, and we know that she's going to put 3 of the kisses in each bag. So in order to figure out how many Halloween bags she can make, picture this. Picture a table with 17 Hershey's Kisses. She has little bags, and she's going to put 3 kisses in one bag, and 3 kisses in another bag, and 3 kisses in another bag. We know the total, and we're breaking it up into groups of 3. That tells me this is a division problem. So I'm going to say 17, which is my total, divided by 3, because I'm putting 3 kisses in each bag. So let's go ahead and divide. First step, give Mrs. Wainwright her chocolate bars. You would not put a chocolate bar over the 1 because that's not the same or more than 3. But you can put a chocolate bar over the 17 because that is greater than 3. So this will be a 1-digit answer. And if I go through my 3 times tables, 3, 6, 9, 12, 15, 18, too high, put 1 finger down, my answer is 5. Multiply 5 times 3 is 15. Subtract 17 minus 15 is 2. Compare is 2 less than 3. Yes, it is. There's nothing to bring down, so I write my remainder. This is a word problem. My answer is 5 remainder 2. And anytime I have a word problem with a remainder, I need to stop and think about my situation to see what I'm going to do with that remainder answer. So this is what I'll think. My answer is 5 remainder 2. That means she can make 5 bags with 2 kisses left over. Now she's making Halloween bags. Would it make sense to take those 2 leftover kisses and break them up into tiny little pieces and put tiny little pieces in a Halloween bag? Of course not. Nobody's going to eat Halloween candy out of a bag with its tiny little pieces. So for this problem, we will ignore the remainder. The question says, how many bags can Mrs. Wainwright make? And the answer is Mrs. Wainwright can make 5 Halloween bags. So for this problem, we had to ignore our remainder. Therefore, we used choice 1, ignore the remainder. For choice 1, the problem does not make use of the remainder, so it can be ignored. Then you only need to write the whole number as your final answer. Don't forget to add the unit since it's a word problem, and we did. It was 5 Halloween bags. That was our unit. Let's take a look at example number 2. Example number 2 says Sadie had 16 friends at her birthday party. Sadie's relatives were driving them to Adventureland. 3 children could fit in each car. How many cars were needed to take Sadie and her friends to Adventureland? First step for a word problem is underline what the question is asking us. So my question wants to know how many cars were needed to take Sadie and her friends to Adventureland. It wasn't just her friends. Sadie obviously was going too since it was her birthday. So let's go back and see what we know. We know that Sadie had 16 friends at her birthday party. So it's Sadie and 16 friends. Altogether, that's 17 people, right? 16 friends plus Sadie makes 17 people. We know that 3 children could fit in each car. So we know the total number of people that are going, or the total number of children, which are 17. Sadie and her 16 friends makes 17 children. And I know that 3 children can fit in each car. I know the total. I'm dividing it into small groups of the same size. That tells me this is a division problem. So I will say 17 divided by 3, since 3 children can fit in each car. Go ahead and put my chocolate bar down. I cannot put 1 over the 1. I do put it over the 7. 3 goes into 17 5 times. 5 times 3 is 15. 17 minus 15 is 2. 2 is less than 3. And write the remainder. 5 remainder 2 is my answer. Again, this is a division problem with a remainder. It's a word problem, so I need to stop and think. So I'm going to think 5 remainder 2 means they need 5 cars, and there will be 2 kids left over. Think about that. If they take 5 cars to Adventureland, 2 kids will be left behind. We can't have that. So we need to add 1 more car for those 2 kids to get to Adventureland. The 5 full cars plus the 1 extra car will be 6 cars that are needed. So the question says, how many cars were needed to take Sadie and her friends to Adventureland? And the answer is 6 cars are needed to take Sadie and her friends to Adventureland. Because of course we're not going to turn around and say, too bad, can't fit you in the car, you can't come. Obviously that's not going to happen, so we had to add 1. So in this case we used choice 2, add 1 to the whole number quotient. In order to take care of all parts of the problem, 1 must be added to the whole number. Then the whole number answer plus 1 is your final answer. Don't forget to add the unit since it's a word problem. So we had 5 remainder 2. Our whole number was 5. We added 1 to that for the extra car for those extra people. So the answer was 6. And in this case it was 6 cars. Cars was our unit. Example number 3 says Jenna made 17 cookies for the school bake sale. She'll make fancy bags with 3 cookies in each bag. Then Jenna will eat what's left over. How many cookies will Jenna eat? Well, this is a word problem, and the first thing I need to do is find out what the question is asking me, so I'll underline it. How many cookies will Jenna eat? That's what I want to know, how many she's going to eat. What are the facts I know? Well, then I know that Jenna makes 17 cookies for the bake sale. That's how many she made, and 3 cookies will go in each bag. So I know the total number of cookies she made, 17. 3 cookies are going to go into each bag, so I'm taking the total and breaking it into small groups of the same number. That tells me this is a division problem. So I have 17 divided by 3. Again, same problem as we've had before, different situation. Cannot put a chocolate bar over the 1 because it's less than a 3, but I can put a chocolate bar over 7 because 17 is greater than 3. I divide, 3 goes into 17 5 times, multiply, 5 times 3 equals 15, subtract, 17 minus 15 equals 2. Compare, is 2 less than 3? Yes it is. There's nothing to bring down, so I write my remainder, and my remainder is 2. So the answer to this division problem was 5 remainder 2, but it's a word problem. And when I have a remainder in a word problem, I need to stop and think it out. When I look at my answer of 5 remainder 2 and I think it out, I think that Jenna made 5 bags and she has 2 remaining cookies. The question wants to know how many cookies will Jenna eat. If Jenna eats the leftovers, and that's what it says in my question, Jenna will eat the leftovers, then she will eat the remaining, or the remainder of what's left over. And I know the remainder is 2, so Jenna will eat 2 cookies. And that's my final answer. So for problem number 3, we used choice 3. The remainder is the answer. The question asks what's left over after something has been divided. Jenna was going to eat the leftovers, so we wanted to know what the leftover was. So then the remainder is the final answer, and you ignore the whole number portion. Again, don't forget to add the unit since it's a word problem. So we had 5 remainder 2. It was my remainder, which was the leftover of what Jenna was eating, was 2 cookies. The unit was cookies. Let's take a look at example number 4. Example number 4 says Kevin has 17 bags of Skittles that he has to share with his 2 siblings. How many bags of Skittles will they each get? Again, this is a word problem. Go back to my question, see what it's asking me, and underline it. How many Skittles will they each get? Let's see what we know. We know there are 17 bags of Skittles, and we know that he has to share them with his 2 siblings. We know that it's not just 2 people that are sharing them because it's his 2 siblings plus Kevin, which means that we're going to have 2 plus 1 equals 3. So there are 3 people that will need to share these 17 bags of Skittles. I know the total number of bags, 17. I know I need to divide them up amongst 3 people. When I have a total and I am dividing it, that's a division problem. So my problem will be 17 divided by 3. Give Mrs. Weiner her chocolate bars. You can't put it over the 1, but you can put it at the end of the 17. So this is a 1 chocolate bar answer. 3 goes into 17 5 times. Multiply 5 times 3 is 15. Subtract 17 minus 15 is 2. Compare 2 is less than 3. That's perfect. Nothing to bring down. And write the remainder. So I have a word problem that has a remainder. I need to stop and think it out. So when I'm thinking of my 5 remainder 2 means that each of them will get 5 full bags and there will be 2 bags left over. But I know that if there's siblings, there's 3 kids, aren't they going to fight over those remaining 2 bags? They're not just going to say, oh well, they're going to fight over who gets them. So what should I do? Well, let's think about it. Can they take those 2 remaining bags, open them, and share what's inside of it evenly? Sure they can. And if you can share the remaining leftovers, then we're going to make it into a fraction. We do this by putting the remainder on top of the divisor. So our remainder is 2 and our divisor is 3. That's 2/3. So they each get 5 full bags and 2/3 of a bag. And therefore, the question says how many bags of Skittles will they each get? Kevin and his 2 siblings will each get 5 and 2/3 bags of Skittles. And that's my final answer. So for question number 4, we used choice 4, share the remainder. We were able to share the remainder so that it becomes part of the quotient. This will result in a fraction or decimal. Right now we're using fractions. Our final answer is the whole number with the fraction. We don't want to forget to add the unit because it's a word problem, and in this case the unit was bags of Skittles. And remember, when you're making the remainder into a fraction, you make remainder as the numerator on top and divisor as the denominator on the bottom. Please stop the video and complete worksheet numbers 1 through 4. Be sure to think through the situation and interpret what to do with each remainder. Good luck with those problems. So to review this lesson, when there's a remainder in a division word problem, we always need to stop and think it out. We need to interpret the given situation from that word problem and figure out what we need to do with the remainder and how it will affect our final answer. Some situations call for us to ignore the remainder, simply just drop it and go with the whole number. In this case, Mrs. Wainwright was making Halloween bags for Halloween with Hershey's Kisses inside. We're not going to take 2 leftover Hershey's Kisses and chop them up into little pieces in Halloween bags. So that wouldn't make sense. Therefore, we would ignore the remainder and we would simply make 5 full Halloween bags. Sometimes we can't ignore the remainder and we need to do choice 2. We need to include that remainder, so sometimes we have to add 1 to the whole number quotient to make sure that everyone is included. In this example with Sadie and her friends at the birthday party, we had 5 full cars with 2 kids left over. We're not just going to leave those 2 kids home. We need to take them as well. So we need to add 1 to the 5 to make it 6 full cars are needed to take the kids to Adventureland. Sometimes the remainder is the answer. They're just looking for how many are left over. So when the remainder is the answer, we just use the remainder as our number. As in this example, Jenna had 17 cookies. She was putting 3 cookies in each bag, and it said Jenna will eat what is left. They want to know how many cookies will Jenna eat. They want to know what the leftovers are, and the remainder is 2. So she ate the 2 cookies. It was just the remainder for the answer. And sometimes it's possible to share the remainder. You put that as part of the quotient. If it's something that is logically possible to break into smaller pieces and share, then you would do that. And remember, when you're going to share the remainder, you turn your remainder into a fraction or a decimal. At the beginning of the year, it will be just turning it into a fraction. Our remainder becomes our numerator, the number on top of the fraction. Our divisor, the number outside of the box, becomes the denominator, the number on the bottom of the fraction. And in this example, that made sense. Kevin and his siblings shared the 17 bags. They each had 5 full bags of Skittle, and there were 2 bags of Skittles left over. Can they open those up and share them? Of course they can. So we made the remainder of 2 into a fraction, 2/3. Since the divisor was 3, it became 2/3. Kevin and his siblings each got 5 and 2/3 bags of Skittles. Good luck with this lesson.